Okay, so for switching circuits, we're looking at multi-vibrators. Multi-vibrator is a device that switches, and depending on the type, it either automatically switches or it manually switches. There are three types of multi-vibrators, namely the monostable, the bistable, and the astable. Right, now the monostable has one stable state. Okay, bistable has two stable states, and then the astable has no stable states. Okay, now what do we mean by stable state? A stable state means that the output will remain over there. Okay, whether that's a logic 1 or a logic 0, or in other words on or off, is irrespective, but it stays in that state, and that refers to its stable state. Now, when we look at the unstable state, it means that it switches out of the stable state and it stays unstable for a duration, and then after the duration has passed, it moves back into its original state. Okay, so for the bistable, that changes manual, and that change is manual because it has two stable states. For the monostable, which has one stable state, it will stay in the low position, and once it is triggered, it will stay in the unstable state for a duration, and then automatically it switches back into the normal stable state. With the astable, none of these states are stable, which means it's in the unstable state, and then after a period it switches to the other unstable state, and then after a period of time it then switches back into the other unstable state. But more on these different configurations at a later stage. Now what we're going to look at are the three different multi-vibrators, and these are the astable, monostable and bistable, and we're going to look at these three as being controlled by the 741 as well as the 555. Now firstly, let's look at the 555 bistable. Right, what this means is we're using the 555 IC, and it has two stable states. Now the circuit diagram, we've got our positive supply voltage at the top, that goes down into my 555 IC, and then on the two inputs I'm going to have two pull-up resistors, let's call them R2 and R1. These are going to connect to switches, and then at the bottom we're going to connect to 0 volts. Now pin 3 is my output, and then I'm going to connect pin 2 and pin 4 onto these two. Now pin 2 is going to be my set switch, and pin 4 is going to be my reset switch, because pin 4 is my reset and pin 2 is my trigger. In order to ensure that this 555 does not trigger due to unwanted or shadow voltages, we are going to ensure pin 6 is connected to ground so that it cannot go above 2/3 of the supply, and pin 1 is a supply pin and pin 8 is the other supply pin. Now when looking at these, we can see that when I've got this configuration with my two switches open. My set will have a high voltage, my reset will also have a high voltage because they are connected to the positive supply. The switch is open so it doesn't connect to ground. My output will be whatever the value was when I switch this device on. Okay. Now when I connect this switch, my set switch, this voltage will go low for a brief period in time. As it goes low, my output will switch into the high state and it'll remain there. It'll remain there until I manually change the voltage by means of the reset button. When I press the reset button for a brief period in time, I've got 0 volts connected onto pin 4, and as a result my output there will switch to 0 and it will remain there again until I trigger it with my set button. It stays in this state and it is controlled manually in both cases. For the 741 bistable circuit, we're going to use the 741 IC and we're going to configure it into the bistable configuration. Firstly, we're looking at our 741, the inverting and the non-inverting pins with a positive supply and the negative supply. This connects to my output voltage. My input is going to connect to a capacitor, which is not really necessary. This is my input voltage, and this will connect to 0 volts to serve as my reference. I will have a feedback circuit over here with RF as well as R1. Let's call that Rn and that is Cn. At this moment we're not going to concentrate on this too much. We just have this configuration to ensure I've got 0 volts on the input when I do not have an input voltage connected. That point there also connects to my 0 volts. Now, the feedback resistor and resistor 1 will develop a voltage that is fed back onto my non-inverting to serve as a reference voltage. The formula to calculate that, beta equals RF divided by RF plus R1. Now this value refers to a percentage of the output voltage that will be fed back. Now if this is a plus 12 and this is a minus 12 supply, then my output voltage will be either equal to plus 12 or minus 12, depending on which state my op amp is in. Now, because I've got the input connected to the inverting input, I know that if I supply a negative voltage, my output on the output voltage will then switch to the positive state. If I supply a positive V in, then my output will switch to the negative because of the inverting. Now what happens is this feedback signal, this percentage is fed back to the inverting, and that serves as a reference. So my input voltages needs to be greater or equal to this voltage developed over RF, and that will then allow for switching to take place. So looking at the inputs, let us accept that we've got a positive voltage on my or negative voltage on my output. Because of that, my voltage on my non-inverting input is also negative at the percentage set by this ratio, and my V in, because there's no signal connected, is 0. Okay. So it'll stay at this state. Now, my output is negative, so I want to switch it positive, which means I need to supply a negative input voltage. A short pulse will allow my output to go to the positive value. As that happens, my reference voltage goes to the positive value, the positive percentage, and these will all stay there until I introduce a positive pulse onto my input. Once I introduce that positive pulse on the input, my output will switch back to the negative supply voltage. That will cause my reference to go back into the negative supply voltage, and that allows us to now wait again for the negative pulse that will switch the bistable into the opposite state.